Hey everyone, Miss B here, and this is Unit 1, Lesson 3, Cumulative Practice Problems for Illustrative Math Geometry. So let's look at these practice problems. Starting with number 1, let's read what our details are. This diagram is a straight edge and compass construction. A is the center of one circle, so that's A right here. Oops, right here with my laser pointer. B is the center of the other, so right here. And we want to select all the true statements, so that means we're allowed to have more than one true statement. And then we are also going to explain how we know. So we're going to select the ones that are true and then say why we know those things. So first off, they say line CD, so that's this line here, CD is perpendicular to segment AB. Now, based on the way this is constructed and what we did on our practice, yes, because these two circles pass through each other's centers. It's using, we're using the intersection points. So yes, this is going to be a true statement. A is going to be correct or true. Now let's look at, well, let's write our little explanation first before we actually say those things. So the reason we gave is that well, it's a well-constructed perpendicular bisector. So we'll say this is a constructed perpendicular bisector, which means that the line CD is going to be perpendicular since we constructed the perpendicular bisector. Okay, well, let's look at choice B. Choice B says point M is the midpoint of segment AB. So that's M right here, and they're saying that's exactly the middle of this piece here. And I would agree. I would say that this is true because although I don't think I put midpoint on my notes for today, the midpoint is the point um, directly in the middle. And since this is a constructed perpendicular bisector, we know that AB is cut equally in half, which means M would be the midpoint. So we can say, since we've already stated that we've constructed a perpendicular bisector, let's say CD bisects AB, and M is their intersection. So because M is on that bisector and on AB, we know it's going to be the midpoint. Okay, statement C, the length AB is equal to the length of CD. So they're saying that AB right here is equal to the length of CD, which is this vertical piece. And we do not know that based on this diagram. So we actually know that it's definitely not going to be true based on the way that these are constructed. So not one of our options. And we don't have to explain why we don't know, but it's always good to have in mind. So segment AM is perpendicular to segment BM. That's our next statement. So let's look at AM is the component on the left and BM is the section on the right. They're not going to be perpendicular to each other because perpendicular means they would make a 90-degree angle, and these are part of the same segment or part of the same line segment. So also incorrect for this one here. Last statement is E. So this one says that CB, so that's the length of this right here, which I'm highlighting with my laser pointer from C to B, plus B to D, so B to D would be right here, that's going to be greater than CD. Now, just based on the drawing, and especially where these are connected, this is going to be true because in order to be the same length, it would have to overlap this line. But because we're taking this detour out to the side, the added length of just these segments here, which is going to be CB and BD, would be longer than our total length of the central point. So we are going to say that this is true. And we can say, I don't know if there's a good mathematical way to say that it takes a detour, but we can say the segments added together will be longer. Otherwise, it would have to lay exactly on top of CD in order to start in one place and end in the same place while being the same length. So we can say otherwise they would have to overlap. And I'll say CD or segment CD completely. And that's it for question 1. So let's look at, we have another diagram here in question 2. Let's look at question 2. So we're going to read, so I'll zoom in on the text here, and then we'll look at our diagram as we discuss. So in this diagram, line segment CD is the perpendicular bisector of line segment AB. So we're going to assume the conjecture that the set of points equidistant from A and B is the perpendicular bisector of AB is true. So the conjecture that they're referencing here, I'm going to underline. The conjecture that the set of points equidistant from A and B is the perpendicular bisector. Oh, I'm getting a little wobbly with my line there. Is the perpendicular bisector of AB. So they're saying we are assuming that this portion in red is true. Now we're going to ask, is point E closer to point A, point B, or the same distance? And explain how we know. So let's look at our actual diagram. And I'm going to label some pieces here if they have not already. Line segment CD is the perpendicular bisector of AB. So we already have our perpendicular symbol inside there. If we want to, we can even add some congruence marks to say that I know it's bisected so that those components have to be equal. What they're talking about for the perpendicular bisector is the entire line of CD. So they're saying that entire line is equal distance from A and B. So I'm going to highlight those pieces. So they're saying this line right here, and we're assuming this to be true, is equidistant from A and B because it is the perpendicular bisector. So now what we're talking about is we want to know if point E, is that closer to A or B? And for us, E is over here on the, it looks like the left side of our blue highlighted line. So if it was on our blue highlighted line of CD, we would be able to say it is equal distance. However, because we don't have that point on the line, we are going to be able to consider it closer to the side that it's on. So because E is actually closer, or is on the side of A, it's going to be closer to A. So we would say it is closer to A because it is on A's side of the line. The other way you can say that, there's the bell, a side of the line. The other way you can write this statement is to say that it's on the same side of the perpendicular bisector as A. I know my phrasing is not entirely academic, so I'll write the academic version of this below. We can say it is on the same side of the perpendicular bisector as point A. So I may do that occasionally with some of my answers. I do like to use less mathematical terms in order to help explain things, and then actually use formal mathematical terms so that we get good practice using them and phrasing things in formal mathematical academic vocabulary. Okay, that's it for question 2. We're going to look at question 3 here. So we have another diagram, and we are starting with 2 marked points, A and B. We're going to try to precisely describe the straight edge and compass moves that are required to construct that triangle. So first off, I would say that we're going to probably construct these circles first. So my first step is going to be construct a circle. Centered at point A. And you can either say passing through B or with radius AB. I like to say with radius AB. We're going to do the same thing to construct circle B. We are going to construct a circle centered at point B, and its radius we can also call AB or BA. So construct another circle. Centered at point B with radius, and I'm going to say BA just because I like to start at the center and then go to the edge when I'm labeling my radius. Okay, so that is the construction of the circle. Now we need to do a couple things. We actually need to mark and label point C, which is our intersection point at the top of our diagram. So let's do that first, and then we'll actually be able to construct the lines that make up that triangle there. So we'll say mark the, or really a point of intersection, so it doesn't have to be the point of intersection. So mark a point of intersection. Intersection of the 2 circles. and label it C, or point C. Last step is going to be to actually construct the three sides of this triangle. So step 4, we're going to say construct segments AB. We need BC and CA. You can also call this AC. Naming conventions work in both directions. And that would give us this full diagram. So that's question number 3. We're going to move on to the back of the page. And we have question 4. So this diagram was created starting with points C and D, and using only straight edge and compass to construct the rest. So that means we know that the circles are circles and the lines are all straight and all of those things. This, to me, this diagram looks like a constructed perpendicular bisector. It's just missing the segment in between C and D at the middle. So what we're supposed to do is, since all of our steps are visible, we're supposed to select all of the steps needed in order to produce the diagram. So we do have to be very careful, especially with names, because if we look at choice A, it says to us here, choice A, construct a circle centered at A. But if I look over here at A, I do not see a circle with this as the center. This is actually a point of intersection. So I like to eliminate my choices if I know they're incorrect, so not that one. Second option is to construct a circle centered at C. And I do see that C is my center here. So we are going to select this one. Construct a circle centered at D. I also see that D is the center of one of my circles, so that step is correct. Next step, label the intersection points of the circles A and B. Just going to double check. I do see that we have A and we have B as the names of our intersection points, so indeed it is this one here. Now, let's look at option E. So E says draw the line through points C and D. And again, names are important. I don't have a line drawn through C and D. My line is actually drawn through A and B here. So they're just trying to make sure you're paying attention. This geometry is very specific with names. So not option E, but option F does describe what they told us, which was that A and B. So draw the line through points A and B. And I believe we're almost done with this assignment because my next one is lesson 4. So one more question. This diagram was also created with a straight edge and compass tool. A is the center of one circle, so they're telling us that. C is the center of the other, and we're going to select all true statements. So I am looking at 2 points here, A being the center of one and C being the center of another. Right, so they told me A is the center. I'm just going to highlight some stuff here, and C is the center of the other. We want to select anything here that is true. So AB is equal to BC. Let's find those 2 points, AB and BC. Now AB is the radius of circle A. It goes from A to the exterior of the circle at B. And CB, or BC, this segment here, is also a radius, but it's not a radius of the same circle. It's a radius of circle C. So I'm going to say this is not true because those do not have to be the same length. So now let's look at AB and BD. AB and BD look pretty similar. AB, again, is that radius of circle A. But BD It starts on the edge of circle A and it lands out here at just another point on the exterior of circle C. And we don't know anything about this construction that would actually tell us these are equal, so we do not know that for sure, which means it's not an answer. Now let's look at option C. So this one here says AD, so that's this entire distance, AD, and that is equal to 2AC. So they're saying that's 2 of this smaller section here. That is something that is true because AD is the diameter, or that segment is the diameter of circle C, while AC is the radius. And I know that the diameter is the same as 2 of the radii. So this one is true because we can say radius, or I'm sorry, diameter equals 2 times radius. Okay, now for D, BC is equal to CD. That is, I'm going to highlight these here, BC is equal to CD. These two segments are going to be congruent because CB is a radius of circle C, and so is CD. So this one is going to be true. I'll highlight these in blue. CB and CD are radii of the same circle. So you can say radii of circle C. And we know that all radii of the same circle are going to be the same as each other. Our last one says BD is equal to CD. And BD is this one here that is not necessarily a radius of either of our circles here. So CD was a radius. So we're not able to actually say that either of these two segments are congruent to each other. It could happen that they are, but we don't know that for sure. So in this case, not true. And we gave our reasons for the two that we did select because we were asked to explain how we know. And that is it for this assignment. So this is Unit 1, Lesson 3, Cumulative Practice Problems.